Good day to all and welcome to a new video. This one devoted to the derivative of trig functions. We're going to keep this at a practical level. We're going to do minimal theory on this. We're also going to review the basic trig functions we need to know in order to be okay here. But before we do any of that, let's take a look quickly at what we have learned recently, since it is always good to have those rules before our eyes. Okay, so what do we know? What do we know? Rule 1, the derivative of a constant is, what's the derivative of a constant? I guess we're starting to know this by now since we've watched the other videos. It is 0. The derivative of x, I guess we know this one as well, so it's 1. The derivative of, if we combine them together, c times x, that is c. Oik. Number 4, what if we actually put an exponent to the x? What is it that we get? Well, yes, we bring the n in front and we subtract 1 from the exponent. We know that. Numero 5, if you have a constant that actually multiplies a function and you want the derivative of that, you can take out the constant and focus your attention on the derivative of f alone. The constant goes out. Number 6, if you add or subtract two functions and you want to prime this, well, it's pretty easy. You get f prime plus or minus, of course, g prime. You can give the derivative to each one. And then the new addenda to the list, the product rule. So f times g, the derivative of that is equal to, I'm going to put it under because I want to save most of this whiteboard, which is so small to actually work out other problems. So this is f prime times g, so the derivative of the first times the second not prime, plus the opposite, the first not prime, and the second one prime. That is known as the product rule, right? The rule of multiplication. And hence the latest one on the list, f over g all prime. I'm also going to put this one under. This is known as, oh, it's very similar, huh? The numerator, very similar to the product rule, f prime g and fg prime, except instead of a plus, it's a minus, and we divide the whole 9 yards with g of x squared. Good. You already have that in your notes. You don't necessarily want to recopy them, but it's going to be useful for us to have them right before our eyes as we discuss trig derivatives. So we're going to take a quick look here at the derivative of mostly the sine function and the cosine function. So what do we need to know basically before we walk into this? Again, just a quick comeback on some very, very elementary and basic notions. We have that sine x, the function itself, is basically in a triangle, in a right triangle, it's the opposite sine over the hypotenuse, right? So it is called one of the fundamental functions. There are two of them, sine x and cos x. Remember cos x, this one is the adjacent side divided by the hypotenuse. These are my two basic functions. Our basic functions, FCTS for functions. And then we have 4 more trig functions that are built upon the sine and the cosine. So the real recall starts here. What is tan in terms of my basic functions sine and cos? Well, tan is sine over cosine, right? Okay. Secant. Anybody knows, anybody remembers what a secant is? Not a secant line in the graph like a tangent line. No, 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 no. Like, this is not a tangent line. This is a tangent function for trigonometry. Secant, as you may recall, is 1 over cos. These are going to be the ones we use the most, but there are two other, namely cosecant. Whoops, that's a C, not an X. At least not yet. Cosecant of x. What is that? You may remember this to be 1 over sine of x. And finally, la cotangente, cotan x. This is 1 over tangent, which is the same as cosine over sine. Okay, well, that is very little review, but it's also what we're going to need in order to move forward with the derivative of trig functions. So, what could I add to this list? So that's the end of the recall. Let us draw a line here for this. And now let me talk to you about what I want to do with you guys today. I want to add to this list two more. I want to have the derivative of sine x. So new rule number 9, the derivative of sine x. Well, that can be proved, and the proof is not difficult, but we've decided to actually focus our attention on the practical segments of the trig, so we're going to oversee the proof completely. Once again, if you're interested in knowing why this result holds, we can always discuss this during office hours on Zoom. I am always open for that. But if we don't do the proof and you accept the fact that the result is what it is, we're going to simply use the fact that the derivative of sine x is cos x. And we're going to have rule 10, which is the counterpart, the derivative of cos x. What do you think it is? Sine x? It's never that straightforward, huh? It actually is minus sine x. So that actually makes a very almost complete view of the basic rules of derivative. You have your 8 rules for general functions and your 2 new rules for trig functions. And with this, we can actually start doing a very nice variety of problems. So we're going to keep that in mind. I'm going to erase this and use all of these 10 rules, not all at the same time, obviously, in order to work out some derivatives. So we're going to get rid of this now. And we're going to focus on problems. Okay. Well, let us start with example 1. Example 1. Evaluate the derivative of f of x is equal to sine x over x squared plus 1. I'm going to add a little something at the end of this question, something you will come to recognize quite a lot. DNS. What does that mean? Do not simplify. So whatever answer we have, we will not want to do any fancy algebra to simplify it. We'll just be happy once the derivatives are taken to actually spit out what the answer is. All right, so what is this? What is the derivative of sine x over x squared plus 1? Well, what do I have here? You recognize this perhaps to be something we've seen before. Jean, I have an upper function and I have a lower function. So I know this function is called f, but I'm going to abuse the language a little bit here, and I'm going to recall this numerator f and this denominator g, such that we recognize what we have here. This is an f over g, all prime. This is to be done using the division rule, the quotient rule, where f is sine x and g is x squared plus 1. So what is the quotient rule? Well, the quotient rule is f prime. Let's start it down. So it's f prime g minus f g prime over g of x squared. All right. Okay, now our f is sine x. It's the upper function. So we shall go f prime, that is sine x prime. Then we shall go times g, and g is the bottom guy. X squared plus 1. Minus, well, we basically switch the prime from one to the other. The first one shall go not prime, and the second one shall go prime. And of course, I will not forget to divide this by g of x all squared. G of x is the bottom, and the bottom is x squared plus 1. That goes squared, not prime. Be careful. All right. Now we got a couple of derivatives in here we have to evaluate. There is a prime right here, and there is a prime right here. Let us see what rules we need to use to figure this out. The derivative of sine x we have just learned. It's our new rule 9. It's cos x. So the answer is cos x times x squared plus 1 minus sine x times, what is the derivative of x squared plus 1? Well, I got a plus here, right? So that's going to be my rule numero 6. That's going to be the derivative of x squared plus the derivative of 1. Tutti quanti, tutta la famiglia, the whole shebang over x squared plus 1 squared. Are we done? We're not done, because we have still a derivative to take here and another one to take there. These are easy. This is rule 4. So I'll take the 2 in front and I'll do minus 1. And this is rule 1, the derivative of a constant. So basically, I think we are done here. Cos x, x squared plus 1 minus sine x times, this is 0, so I'm not going to write it down, and this is just 2x to the 2 minus 1, that is 2x to the 1, all of that divided by x squared plus 1 squared. All right, let's not do any crazy things. I cannot simplify those two guys because it's not factored out, right? It's present in the first part, but it is not present in the second part, so it's not factored out. If it's not factored out, there is no simplification possible. So that is my final answer. That's it. That's what you want a box. And that's example 1. Okay, good. Let's see if we can do something else. Moving on to example 2 in 2, 1, 0. All right, exemple 2. Example 2. Find the derivative of tan x. Find the derivative of f of x is equal to tan x. And for this one, ds. What does ds mean? Of course, do simplify, right? DNS, do not simplify. DS, do simplify. So looking for f prime of x, the derivative of f. So looking for the derivative of tan. All right. How can I do that? Well, we just reviewed this before, yes? What is tan? Tan is sine over cos. Oh, interesting. Tan is sine over cos. So I am currently looking for the derivative of sine over cos, which is what? A quotient. Claro. Another quotient. Another f over g. I know I shouldn't actually call f tan and f the numerator here, but there it is. So this is a numerator called sine and a denominator called cos. So I need to do again my quotient rule on this. What is the quotient rule? The quotient rule, let's do it over here. The quotient rule is f prime g, we know this, minus f g prime over g squared. All right, we know that f is sine, g is cos. So what is that? F is sine, g is cos. And then we reverse. The prime will not go to the sine, but it will go to the cos. And that is over g squared. G is the bottom, cos, so cos squared. All right. So that's an occasion to apply the two new rules we have today, namely the derivative of sine and the derivative of cos. Derivative of sine is what? What's the derivative of sine? Yeah, it's cos. You're right. So that's cos times cos minus sine times what is the derivative of cos x? What's the derivative of cos x? Rule number 10, minus sine x all over cos squared. Now once again, warning sign, do not cancel cos times cos, cos squared with this cos squared, because there's a minus linking those two, and cos squared is not mise en évidence. It is not factored in front. Can't do that. Don't do crazy stuff. This is just cos squared, because cos times cos. And here, watch this. Minus and minus, that is a plus. Sine times sine is sine squared. All right. Getting someplace. Over cos x all squared. Once again, don't cancel cos squared and cos squared, which, by the way, I have written in two equivalent ways. This is cos squared. This is cos squared. These two, you're going to see them alternatively written one way and the other. They both mean the same thing. And no, I cannot cancel them. But what can I do? I can actually do a little bit of a recall of a trig identity that I have seen in high school. Recall, trig. It's the basic one, really. Trigonometric identity. The Pythagorean one, if you want, which goes sine squared plus cosine squared. Come on, you remember this. I know you do. What is sine squared plus cosine squared? 1? You're totally right. This is equal to 1. So, GTK, good to know. Sine squared plus cosine squared is equal to 1. So look, your entire numerator here is equal to 1. Cosine squared plus sine squared, this is 1 over cosine squared. Are we fully simplified? After all, this question actually said you need to simplify. Do simplify. Are we fully simplified? Well, what do you think? Can I do more? Well, I think we can do more. 1 over cosine squared may be written again as what? Like this. 1 over cosine with the square outside, isn't it? Because 1 squared is 1, cos squared is cos squared. And now you know something. What is 1 over cos? We just reviewed that at the beginning of this video. What is 1 over cos? It is secant. So this entire derivative boils down ultimately to this. The derivative of tangent is secant squared. That we're going to meet quite often, so it deserves a box. The derivative of, so conclusion, the derivative of tan x is equal to secant squared. I'm not going to make this my rule number 11 or something, because I want the rules just to stay for sine and cosine. But this is good to know as well. That's going to pop up every now and then in this chapter on trig derivatives. So you may box this if you want in your notes. It is something that will be useful at least at certain times. And this is how you would do, using the quotient rule, the derivative of tangent. Good. All right, moving on to another application of this in 2, 1, gone. All right. Okay. All right, what could we do here? Example 3. Let's maybe add a layer, if you want, to what we have done so far. Find the slope of the tangent line. Okay, we haven't heard this statement in a while, and in our solution we're going to have to recall what this stands for. Find the slope of the tangent line to the graph of f of x, to the graph of f of x is equal to secant of x. Let's use another function here. At the point pi minus 1. So find the slope of the tangent line to the graph of secant x at the point pi comma minus 1. All right, like I said, there's a little bit of a statement here, slope of the tangent line, that we haven't encountered in a while, but I hope you did not forget that the slope of the tangent line is the same thing as what? Slope of the tangent line is the same thing as the derivative. So recall, before we dive into this problem, recall the slope of the tangent line at x equals a, if it exists, of course, if it exists, is f prime at the point A. So slope of the tangent line means derivative. Slope of the tangent line means derivative, provided, of course, this derivative does exist. Okie dokie, so I guess the first order of business is to find the derivative of the function secant x. Once we have that, we can plug in the point pi comma minus 1, and that should give us the slope of the tangent line at the point pi. So, what is f prime? What is f prime of x? Okay, well, f prime of x is the derivative of secant. That's the derivative of secant. And what is secant? Well, we reviewed that at the beginning of this video. You remember, I'm sure. It's 1 over cos. Oh no, not another quotient rule, for crying out loud. All right, another quotient rule, you can cry out loud, 1 prime times cos, so f prime over g minus f over g prime over g squared. Did I go a little fast over this? Let me take a step back. This is my upper function. This is my lower function. And I'm providing here a division. So this is f prime g minus f g prime over g squared. This probably simplifies because 1 prime is what? That's rule 1. That's rule 1. That's 0. So 0 times cos, baby. Minus 1 times, what's the derivative of cos? That's rule 10. So we're using the first and the last rule in our list. So that is minus sinus of x over cos squared. All right, let's make an effort to simplify this a little bit, shall we? Qu'est-ce que c'est? 0 times cos is 0, so this is just sine x over cosine squared. And I'm going to write this in a peculiar way. Here's what I would like to do for the sake of simplifying. This is sine x over cos squared, okay? And so is this. This is sine x over cos squared because sine times 1 is sine, cos times cos is cos squared. And that gives us our derivative. Sine over cos is what? Sine over cos is what? Sine over cos is tangent. 1 over cos is what? It's secant. Ha! So it appears that the derivative of the function secant is known to be tangent secant or secant tangent. Okay, so the slope of the tangent line now, the slope of the tangent line, ATG, is f prime at x. What is the x here? The x is pi. We have very little use for the y component of minus 1. So what is the derivative? This is the derivative. So it is tan pi times secant of pi. That's what it is. Because that's secant tangent, right? This is the derivative, the answer we obtained for the derivative of secant x. So all we got to do is actually put that into the calculator and we should be done. That is sine pi over cos pi times 1 over cos pi. Sine pi is 0, cos pi is minus 1, and cos pi is minus 1. So that is 0 times minus 1. What is that? What is 0 times minus 1? The answer is 0. The slope of the tangent line is actually equal to 0. So if you think about it, the slope of a line being 0 means that the slope being 0 means that the line is like this, right? This actually means, let me change colors. It means that whatever the graph is, then the slope of the tangent line is actually going to do something like this, right? It's going to be a horizontal line. Why? Because only horizontal lines have a slope of 0. Okay, so I guess that's probably enough for one time. We'll continue building on more of these trig functions in the next video. But for now, I wish you well, and I'll see you on Zoom. Bye-bye.